So whenever we talk about autonomous vehicles in future cities, we tend to imagine cities that are like this kind of like futuristic places where there is like a very efficient traffic flow, where all the vehicles are connected, traffic is very efficient, there is no congestion, there is no traffic accidents. But the problem with this vision of future cities is that they are still like very car-centric. So as such, by making car use more efficient and attractive, this vision comes at the risk of further perpetuating car dependency, and therefore the negative consequences that it has brought into our cities and societies, right? So as part of our group in City Science, we have been wondering, why don't we apply this same technology, autonomous driving technology, but to vehicles that are much more lightweight and sustainable, so that we incentivize those instead. So as part of this idea and this vision, we have been developing different types of lightweight autonomous systems. So for example, we have the Persuasive Electric Vehicle, or PEV, which is an autonomous three-wheeler that you can order on demand through a mobile app. Then it drives autonomously to wherever you are. And the idea is that then when it gets to the user, it goes into non-autonomous mode, and then you can pedal it to your desired destination just as a regular vehicle. We also have translated this same technology into a bicycle sharing system that's called the MIT Autonomous Bicycle. And the challenge in a bicycle is that by having only like 2 wheels, a bicycle wouldn't be stable and it would tend to tip over to the side. So that's why we designed a mechanism that has 2 wheels in the rear, so that it is a tricycle when it's driving autonomously, but then it converts into a bicycle for riders to use. So in the end, like, we are exploring this field of that we call the autonomous micromobility, with the hope of seeing how we can align this technology, autonomous driving technology, and the advancements in that field with this vision of creating much more human-centric and sustainable cities. And then as part of this research, we have not only prototyped this type of vehicles, but we have also been looking at their fleet-level performance and potential implications. So we have, for example, done some studies where we compared the fleet size that we needed for the same demand in Boston for serving like thousands of trips in a week, how many autonomous vehicles we would need compared to the current station-based or dockless systems. And we have seen that we can reduce fleet sizes by 3.5 to 8 times. So we have seen like this potential for reducing the number of vehicles that we need by a lot, thanks to autonomy. And then, for example, we have also done other studies, but I would like to highlight maybe one in which we looked at the environmental impact, because it could have been the case that, okay, you need fewer vehicles, but then the environmental impact of the system is higher, right? But we have seen that we can also reduce the environmental impact by 38 to 60%. So this has been kind of like some of the learnings that we have had of how these systems would work at a fleet level and what their potential implications could be in cities. So thinking into the next steps of this research, one of the things that we had learned through doing all this modeling and understanding how the system works is that while non-autonomous vehicles are used like 42% of the time, and then we have seen that in autonomous vehicles, this is much higher, it's 8%. So there is a 4-fold increase in the vehicle usage. And in the end, this means like this is what translates into these big reductions in fleet sizes, as well as in environmental impacts, as I just mentioned. And I guess that still with this, it comes like the other side of it, that it's like, okay, 8% is a great usage level, but still there is a 92% of the time when the vehicles are not being used. So we are exploring like what if, for example, the same vehicles that have been used as a mobility on-demand system during the morning rush hour, maybe they could perform other tasks throughout the day. So for example, they could bring food at lunchtime, deliver packages in the afternoon or at night, pick up trash. So we have started in exploring this vision of having multifunctional systems that would perform different tasks throughout the day. And we have done a first case study in Cambridge, which is where MIT is located. And we have developed a type of model that is called an agent-based model to study the performance of this system. So we had vehicles that could serve both types of demand. And we saw that if you had vehicles that could only serve the mobility on demand, for example, and then another fleet dedicated to only food deliveries, the total fleet that you need is around, say, like 400 and something vehicles, right? And then if we had multifunctional vehicles instead, we can reduce that fleet size by 20%, 22% to be precise. And this is only by combining two different types of services, but we hope that as we further increase the types of tasks that these vehicles can do in cities, we can further reduce the number of vehicles that we need. And the implications of this are that on one hand, we will be able to reduce the embodied environmental impacts of mobility services, but at the same time, this could also like open up more free space in cities for pedestrians to enjoy. So those are like some of the implications that we are seeing from that research. But then at the same time, thanks to the collaboration that we have with Gipuzkoa, we are also looking at how this system and how this model that we did for Cambridge translates to the specific case of San Sebastian. So we are looking at those same type of demand in here locally, because we think that maybe the types of demand that it makes sense to combine can be different for different cities because of their unique networks and demand characteristics. So this is why having this type of collaborations is so exciting for us in trying to see what are the implications of this type of ideas, big ideas and models in having like an impact locally in improving mobility in Gipuzkoa. Currently, we are working on transferring the same model to a case study in San Sebastian, looking at these two types of demand of mobility on demand and food deliveries. And the reason for doing this case study is that we think that maybe the types of demand that it makes sense to combine can be different for different cities because they're unique networks or demand characteristics. And this is why having these collaborations, like the one that we have with MUBIL and Gipuzkoa, can be so interesting for us to understand like what are the implications of this future mobility, but for it to have like a local impact here in Gipuzkoa.